Hello my dear students, welcome to IMS GATE Academy. I hope all of you attended the last two sessions regarding digital circuit subject. I hope all of you learned a lot from the last two sessions. Okay, so if any of you couldn't attend any of the last two sessions regarding digital circuit subject, so all of you can attend those sessions in your free time. Okay, so in this particular session we are going to start the continuation of the previous sessions. Okay, so here this is the last session regarding digital circuit subject regarding gate score booster. Okay, so this subject is common for 4 branches, as I mentioned earlier also: EC, electrical, instrumentation, computer science. So all of you kindly share this video link with all of your friends so that they also will attend this session in live and they also will get benefited from this session. Yeah, very good evening Savik, Saptak. Yeah, very good evening one and all. How are you all? Yes, fine, very good. So regarding digital circuit subject, just one second. Yeah, regarding digital circuit subject, in the first session we have covered the questions related to the first two chapters. In the yesterday's session, we have discussed the questions related to third and fourth chapters. So in this session, we are going to focus on these 3 chapters. Okay, we will discuss the questions related to sequential, related to data converters, and related to CMOS logic family. Whereas for CS branch, the syllabus is up to sequence circuits, whereas for electrical branch, the syllabus is up to data converters, whereas for EC and IN, up to CMOS logic family. Okay, for today's session, irrespective of the branch, all of you can attend the entire session, but according to your exam point of view, so according to the respective branch, you can go through the corresponding chapters. Yeah, very good evening, Nikhil. Very good evening. So all of you please respond. How many of you are eagerly waiting to start with the first question from the sequence circuits chapter? Yes, everyone, right? Very good, very good. So in this particular chapter, so we'll discuss the questions based on flip-flops, then shift register, and then counters. So these are the very, very important topics for all the 4 branches. So we will discuss the questions related to these topics one by one. Yes, very good Kundan, very good Savik, Nikhil. Yes, very good. So this is the first question. It is MCQ. That means only one option will be correct. Among the 4 choices, only one option will be correct. Yeah, thank you, Pragya. So this is the MCQ. You're having one SR flip-flop. You're having SR flip-flop. They have given SR inputs as S is connected to Q bar, S is connected to Q bar, and R is connected to Q. R is connected to Q. And here you're having clock signal. So regarding the clock signal, they have given the time period as 10 microsecond, 10 microsecond. And they are asking the frequency of the Q signal, frequency of the Q signal. That means this particular Q signal output, okay, regarding that they are asking the corresponding frequency. Yes, all of you try this question. Yeah, thank you, Nikhil. I will disclose the correct answer after some time. So meanwhile, after solving this question, whatever the answer you are getting, you can mention. Yes, well tried, Mr. N. Pragya sir. Yes, very good, Kundan, Nikhil, Saptak. Yes, very good, very good. Option D is the correct answer. Option D is the correct answer for this question. See, whenever you are getting any question related to flip-flops, okay, sometimes they will give single flip-flop and with the help of some feedback connections, they will make the circuit, or sometimes they will give some logic gates with the help of logic gates and some through feedback method, okay, they will give the inputs for the each and every flip-flop, okay. So sometimes they will ask, identify the given circuit, sometimes they will ask regarding the output, either frequency or time period, etc. Right? So whatever may be the question related to flip-flop, shift register or counter, okay, the basic procedure is simple. What you have to do, whatever the given flip-flop is there, first you have to write the characteristic equation. Yeah, good evening, Anuradha. Good evening. Very good evening. So first you have to write the characteristic equation of given flip-flop. So regarding SR flip-flop, we know that characteristic equation is Q of t plus 1 equal to S plus R bar into Q of t. S plus R bar into Q of t. Right? So in this question, S is nothing but what? Q bar. S is nothing but Q bar. Just substitute here. According to the given question, S is nothing but Q bar. Plus, here R is nothing but Q. R is nothing but Q. R is nothing but Q. Q of t. Since you are having complement, we have to place that complement as it is. And then Q of t. So Q bar into Q, you will get 0. That means here Q of t plus 1 is nothing but Q of t bar. Q of t plus 1 is equal to Q of t bar. Yes, very good, Saptak, very good. So this is the characteristic equation of, see, this is the characteristic equation of SR flip-flop. After that, according to the given circuit, we substituted S input, R input. After that, you got the simplified expression, right? So whether it is flip-flop or register or counter, okay, whenever you see register or counter, inside register or counter, you will be having the flip-flop, right? So that means all the circuits, flip-flops, registers, counters, right? So all those are operating with what? Clock signal. Clock signal. And here if you observe, you are having one arrow mark that indicates what? Positive edge. Positive edge. If you are having bubble here, that means it is a negative edge, but here you are having just edge only. So that means whenever clock signal changes from 0 to 1, see, just observe here, 0 means 0 volt, 1 means 5 volt. So that means whenever clock signal changes from 0 to 1, that means low to high, it is called positive edge trigger. Positive edge trigger, right? So whenever, see, here you will give periodic square waveform. Whenever the clock signal changes from 0 to 1, that time only your next output will be complement of the previous output. Okay, Q of t plus 1 equal to Q of t bar whenever clock signal changes from 0 to 1. Whenever clock signal changes from 0 to 1. That means for every positive edge of the clock signal, here the output of the flip-flop will get complemented. Yes, good evening, Shubodh. Okay, up to here, is it clear for everyone? This is very, very important. Once if you understand this one, you can solve any question related to flip-flop, shift register, counter. Whatever may be the configuration they may give, this is the procedure. All of you please respond. Up to this point, is it clear or not? If it is clear, we'll proceed further regarding the frequency of the signal. Yes, I hope it is clear for everyone up to this point. Okay, now let us draw the waveform. So first I am drawing the clock signal periodic square waveform. So whenever clock signal changes from 0 to 1, that is called positive edge. Positive edge. Okay. Now let us draw the waveform for Q. Now let us draw the waveform for Q. See, initially, just 1 second. Yeah, initially when there is no clock pulse applied, for the time being, I am assuming the flip-flop output is 0. Okay, sometimes in the question they will mention either the flip-flop output is 0 or sometimes they will mention as 1. Okay, whenever they don't mention, you can assume that either 0 or 1, no problem. But for general purpose, okay, most of the questions, whenever they don't specify, we can assume the initial state as 0, right? So here first time positive edge of the clock signal I am getting. So just now we got the equation as what? Q of t plus 1 equal to Q of t bar, okay, whenever you are getting positive edge of the clock signal, right? So here first time positive edge of the clock signal I am getting. So earlier value is 0, now it will become 1. 0 will become 1. So this value will remain until till you are getting next time positive edge. See here first time positive edge of the clock signal I got, so that time only output will get complemented. Now here we are getting second time positive edge of the clock signal, right? So now since you are having just before the positive edge of the signal, since you are having the previous value as 1, now it will become 0. Now it will become 0. Now this value will remain until you are getting next time positive edge of the clock signal, right? So now since you are getting positive edge of the clock signal, now what will happen? Your previous value will get complement. So like this process will continue further. Yes, very good evening Vipin, very good evening. Okay, I hope it is clear for everyone up to this point. Okay, even though you got the final equation as Q of t plus 1 equal to Q of t bar, but this will happen only whenever positive edge of the clock signal occurs, right? Because here in this question they have mentioned positive edge. Suppose if they mention bubble here, that means whenever clock signal changes from 1 to 0, that time only this particular phenomena will happen. Whether it is positive edge or negative edge, final answer for this question will remain same. Yes, very good evening Pratik, very good evening. Okay, whether it is positive edge of the clock signal or negative edge of the clock signal, the final answer will remain same for this question. Okay, now just carefully observe. Here, see, you might have studied in your signals and system subject regarding periodic waveform and aperiodic waveform, right? So if you observe clock signal, this particular pattern 1 0 combination is going to repeat, right? Whatever the pattern is going to repeat, then that particular pattern duration we will call it as period of the signal, right? Period of the signal. Since I have considered this signal name as clock, so accordingly I am giving this time period as t suffix clock. Okay, whenever a particular pattern gets repeated, then that particular signal or waveform we used to call as periodic signal or periodic waveform, right? Now just observe, this is your Q waveform. Here if you observe, here you are having 1 and then 0. This 1 0 combination will get repeated, right? So that means this Q is also periodic, yes or no? The pattern 1 0, this particular configuration or pattern is going to repeat. So that means Q is also periodic. So now can you tell the time period of this particular Q waveform? All of you just observe the waveform and tell me what is the time period of the Q waveform. Yes, very good Kundan, very good. See, here you are having time period of the clock signal. This period is clock signal time period, and once again you are having the same time period of the clock signal, same time period of the clock signal. So you are having 2 times clock signal time period, that is nothing but your time period of Q waveform, right? So time period of the Q waveform is nothing but 2 times clock signal time period. So in the question they have mentioned the clock signal time period as 10 microsecond. 10 microsecond. So that means 2 into 10 micro. So that means you will get 20 microseconds. 20 microseconds. Okay. Here if they ask the time period of the Q waveform, then the answer will be this one. Okay. But in the question they have asked the frequency. I hope all of you know the relation between frequency and time period. So frequency is nothing but 1 by time period. Frequency is nothing but 1 by time period. So just substitute this value here. 1 divided by 20 micro. Micro I am writing as 10 power minus 6. This 10 power minus 6 when you bring to the numerator, it will become positive, right? So numerator it will become 10 power 6. So for the time being I am just representing it as 1000 into 1000. 1000 into 1000 just for easy calculation. So here 0 will get cancelled 250 times. This 1000 you can write it as kilo. 1000 you can write it as kilo. So that means you are getting 50 kilohertz. So the answer for this question is 50 kilohertz. So option D is the correct answer. Option D is the correct answer. See, suppose in this question they have asked regarding the frequency of the Q signal. Okay, instead of that, if they have given simply the circuit and if they asked identify this particular circuit, now can you guess what this particular circuit represents or identify this overall flip-flop? Can you guess? Yeah, it's not NOR gate. Okay, I will discuss. Just 1 second. See, first write the characteristic equation of flip-flops. Characteristic equation of flip-flops. Q of t plus 1 is equal to S plus R bar Q. This is for SR flip-flop. For SR flip-flop, this is the characteristic equation, S plus R bar Q. Yes, very good, Kundan, very good. Next, regarding D flip-flop, Q of t plus 1 equal to D flip-flop. Next, regarding JK flip-flop, Q of t plus 1 equal to JQ bar plus K bar Q. JQ bar plus K bar Q. And regarding T flip-flop, characteristic equation is Q of t plus 1 equal to T XR Q. T XR Q. Okay. See, these are the characteristic equations of each and every flip-flop. These are the 4 flip-flops we are having. Okay. You have to remember these 4 characteristic equations. If you are able to remember these 4 characteristic equations, whatever may be the question related to flip-flop or register or counter, you can easily solve. Okay. As I already mentioned that all the flip-flops are edge-sensitive devices. Okay. Sometime in the question they will mention positive edge trigger, sometime they will mention negative edge trigger, right? Whatever the final equations here you are having, that particular phenomena will occur according to the respective edge they have mentioned in the question or circuit diagram, right? Okay. So here if you observe, say for example, if S equal to X and R equal to X bar, if I consider like this, that means what I have done, I have considered SR inputs in such a way that those two are complement each other. Yes, Kundan, you have to remember only these 4 characteristic equations. That is more than sufficient for solving any question related to flip-flops. See, it is very simple. Regarding D flip-flop, whatever the D input you are having, that will come at the output whenever the respective edge of the clock signal occurs. Okay, regarding T flip-flop also it is very simple. T XR Q. Okay, so regarding SR flip-flop and JK flip-flop, just remember S plus R bar Q, here JQ bar plus K bar Q. Okay, with practice you can remember, right? So if SR inputs are complement to each other, then what will happen? Just substitute here. Q of t plus 1 equal to here S is nothing but X plus here R equal to X bar, that means R bar will be what? R bar will be X bar whole bar. That is nothing but X, right? So just substitute here X plus X into Q. So from these two you can take X as common. If you take X as common, 1 plus Q you will get 1 plus Q. In the last class we have mentioned, even in the before day class also we have mentioned, here plus symbol indicates logical OR symbol. 1 plus anything is 1. 1 plus 0 is 1, 1 plus 1 is 1, right? So that means you are getting simply X. Now just observe this final equation with these equations. It is matching to this equation. Here you are having Q of t plus 1 equal to D. Here you are having Q of t plus 1 equal to X, right? So that means if X equal to D, then it is a D flip-flop. If X equal to D, then it is a D flip-flop. That means what is your observation point here? For a SR flip-flop, if the inputs are complement each other, then SR flip-flop becomes D flip-flop. Okay. Now all of you try once regarding JK inputs. If JK inputs are complement to each other, then JK flip-flop will become which flip-flop? All of you try. J equal to X, K equal to X bar. Then K bar will be X. If J and K inputs are complement, just substitute. Just like here, just substitute here and tell me what is the overall flip-flop. Kundan, you can cross check once. Here I am not saying J and K inputs are same. Here J and K inputs are complement. Yeah, most of you are getting T flip-flop. Okay, see, I not asked that if J and K are complement. Okay, no issue. All of you pay attention here. You are having characteristic equation of JK flip-flop here. Q of T plus 1 equal to J Q bar. Here J I have assumed X into Q bar plus. Here you are having K bar. K bar is nothing but X. K bar is nothing but X into Q. From these two we can take X as common. X as common. Then Q bar plus Q. Q bar plus Q. See, if it is 0, this will be 1. Or if this is 1, this will be 0. 0 plus 1 or 1 plus 0 is nothing but 1. So that means simply you are getting X, right? So now if you compare with these four standard equations, if X equal to D, then it is a D flip-flop. If X equal to D, then it is a D flip-flop. Yeah, no issue, Savik. Yeah. So here one important point is regarding SR flip-flop, regarding JK flip-flop. If the inputs are complement to each other, then SR flip-flop will become D. Similarly, JK flip-flop will become D. Okay. Okay, so this is the first important point. Whenever in the given circuit, okay, if SR inputs are complement or JK inputs are complement, then SR flip-flop and JK flip-flop will become D flip-flop. D flip-flop. Okay, right. Yes, correct, Kundan, correct. Okay, now if here, now let us consider JK flip-flop. If J and K are equal, regarding JK flip-flop, if you consider J and K both are same, then just substitute in this equation. Now most of you given already answer, so that will be correct in this case. Q of T plus 1 equal to J is nothing but X into Q bar plus K is nothing but X bar, since you are having bar, X bar into Q. So now it is in which form? A B bar plus A bar B is nothing but A XOR B. A XOR B. So that is nothing but X exclusive or Q. So if you consider X equal to T, then it is matching to T flip-flop characteristic equation, right? So that means whenever J and K inputs are same, then JK flip-flop will become T flip-flop. JK flip-flop will become T flip-flop. Okay. Now in the T flip-flop characteristic equation, if you consider T value as 1, then what will be the characteristic equation? Simplified characteristic equation will be what? Just substitute in the place of T1, you will get 1 XOR Q of T. 1 XOR Q of T. So just simplify this one. What you will get? Tell me. Yes. See, just write A bar B plus AB bar. Right? A XOR B formula. Here 1 bar. 1 bar is nothing but 0. 0 into Q is nothing but 0. Plus 1 into Q is nothing but Q of T. 1 into Q of T bar. 1 bar into q of t, that factor will become 0, plus 1 into q bar is nothing but q bar. So that means whenever for a t flip flop, if you are keeping t value as 1, what will happen? Your next state will be complement of present state. So this particular phenomena will happen for every respective positive edge or for every respective negative edge of the clock signal according to the given flip flop. Okay. So now if you observe, they have given this circuit. Okay, first we have written the characteristic equation of given flip flop, and according to the inputs we have substituted here, and then we got the simplified function as q of t plus 1 equal to q of t bar. Now this equation is matching to this particular equation, right? So now we can say that the given circuit is a t flip flop. The given circuit is a t flip flop which operates in toggle mode. T flip flop operates in toggle mode. Okay, T stands for toggle. D stands for data or delay, like that. Okay, I hope it is clear for everyone. Regarding whatever may be the question, okay, related to flip flops, okay, you flip flops, resistors, counters, the same procedure. Okay, first you have to write the characteristic equation of given flip flop, and according to the given inputs substitute it and then do the simplification. And sometimes they will ask in terms of the waveforms, sometimes they will ask in terms of the frequency or time period, etc. So accordingly you can go. Okay. Now the next question, this is the MCQ. So that means only one option will be correct. Okay. So here they have assumed present state and next state of a JK flip flop as, here present state q of t equal to 0 and next state q of t plus 1 equal to 1. So that means present state is 0, next state equal to 1. Okay. So in order to get like that, so you have to identify the inputs. J input, K input you have to identify. Regarding that they have given 4 choices. You have to choose the correct one. All of you please mention whatever the answer you are getting. You can do verify option by option, you can do the verification, or just now we have discussed characteristic equation. So based on your convenience, you might be already familiar regarding truth table. Okay, or with the help of characteristic equation also you will get the same answer. Yeah, Anuradha, you are well tried. Yes, very good, Apeksha, Saptak, Nikhil, Kundan, Savik. Yes, most of you are getting option B. Yes, option B is the correct one. Yeah, good evening, Gopal. Option B is the correct one. See, just now we have told regarding JK flip-flop characteristic equation. Yeah, no issue, Anuradha, no issue. So just now we have discussed regarding JK flip-flop characteristic equation. So first write the characteristic equation of JK flip-flop. Q of t plus 1 is equal to JQ bar plus K bar Q. JQ bar plus K bar Q. Now, in the given question, they have mentioned that the present state is 0. The present state is 0. And next state is 1. Present state is 0 and next state is 1. So just substitute here. Just substitute here. Here next state is 1. J value we don't know. K value also we don't know. Okay, you write as it is. Because we have to identify, right? Those two inputs we have to identify. Now, Q value they have mentioned 0. 0. That means since you are having complement, we have to keep as it is. Here it is normal form. So just substitute the present state. So whenever you are multiplying any term with 0, you will get 0. And when you are adding 0 to anything, resultant value will remain same, right? So that means here 0 bar is nothing but 1. So finally what you are getting? J equal to 1. J equal to 1. Is it clear? What I have done, I have written the characteristic equation of the JK flip-flop. And then since they have mentioned present state is 0 and next state is 1, so just substitute. Okay, in the entire equation you are having present state, here normal form, here complement form, here next state you are having. So just substitute the values and from here we got J equal to 1. J equal to 1. So J equal to 1, here you are having only one option. Just observe, J equal to 1, you are having only one option, straight away you can choose. Okay, and even if you observe, here in this case, after doing simplification, you are getting only final value as J, that value become 1. So that means whether you will consider K value 0 or 1, whether you consider K value 0 or 1, it doesn't matter. It doesn't matter. Okay. So that means either 0 or 1. So for generalized case, we will represent it as X symbol, right? So J value should be must and should 1. K value could be anything among 0 and 1, right? So in this way, you can solve any question even related to SR flip-flop or D flip-flop or T flip-flop also. Generally, related to this question, most of the times, okay, you might have solved with the help of excitation table, but as for GATE exam point of view, they won't ask the questions related to design because it is the objective oriented question. So most of the times, whatever the earlier question you are having, so like that configuration they will give, or like these cases they may give either that question or this question. Any of the questions you can solve with the help of characteristic equation. That's why I have stressed multiple times that if you remember the 4 characteristic equations of flip-flops, you can solve any question related to the entire sequence circuits. This is the basic thing. Okay, right. Yeah, thank you, Gopal. Now the next question, this is related to shift register. Here they have given MCQ, that means only one option will be correct. They have given 4-bit serial in parallel out shift register. You are having one shift register. For this particular shift register, you are having one input. That means bit by bit it is coming. Okay, so this is the serial input, and then you are having 4 outputs. Because it is a 4-bit shift register, you are having 4 bits. So internally the shifting is taking place like this: QA, QB, QC, QD. So that means right shift operation is taking place. Okay, see, sometimes they may mention left shift also, like that. Okay, so in this particular case they have mentioned right shift. Okay, so that means internally the shifting is taking place like this. Okay, and here regarding the serial input, if you are giving externally from your side, if you are giving, then just for the timing, just remove this logic gate. Then this particular circuit we will call it as shift register, because you are giving external input bit by bit serially from your side, and internally the shifting is taking place. Because of that we will call it as shift register. But here this particular serial input from your side you are not giving externally, rather here in this circuit they have given what? They have passed QB, QD these two inputs, they have passed through the XNOR gate. So this particular output they have given as serial input. So that means this particular shift register will repeat good number of states. Okay, for the moment if you are giving respective edge of the clock signal, here they have mentioned positive edge of the clock signal. So that means when you are giving first time, second time, third time, fourth time, like that, okay, after applying good number of positive edge of the clock signal, right? So it will produce some amount of finite number of states. Those states only will get repeated. Okay, whenever whatever the set of states you are having, if that particular circuit is repeating, then we will call it as counter. Overall configuration we will call it as counter. Okay, right. So in this question what they have asked is, so you will analyze what kind of states this particular circuit is producing, and among which here this is one of the main keyword. They haven't asked what are the states this particular shift register is going to produce. Instead of that, they're asking which of the following state will not be produced by the above configuration. By the above configuration, they have given 4 choices. You have to choose the correct one. Yeah, some of you already tried. Other students also please try, and whatever the answer you are getting, please mention in the chat. I will disclose the correct answer after some time. Yes, very good, very good. All of you are getting correct answer. Very good. Apeksha, Kundan, Saptak, Savik. Yes, very good. Option D is the correct answer. Option D is the correct answer. See here they have given one shift register. For this particular shift register, the serial input is the output of this XNOR. So that is nothing but QB exclusive NOR QD. QB exclusive NOR QD. So this is your serial input. Okay, and you are having 4 outputs. And here they have mentioned initial state as 4 zeros. Okay, sometimes they will specify, sometimes they won't specify. Whenever they don't specify, you can assume all the bits are 0, but sometimes if they mention other than zeros, accordingly you have to choose the same thing only. Okay, right. So first you have to make one tabular form. So here, since I have mentioned already that all the flip-flops, registers, counters are edge-sensitive devices, here it is mentioned positive edge of the clock signal. So that means for every positive edge of the clock signal, okay, here shifting operation will take place, right? So first column is the corresponding positive edge of the clock pulse number, like first time, second time, third time, like that. Okay, and second column is serial input, which is nothing but QB XNOR QD, which is nothing but QB exclusive NOR QD. And you are having 4 outputs, you can represent here QA, QB, QC, QD. Now, first I will write when there is no clock pulse applied. When there is no clock pulse applied, in the question they have mentioned the initial state as 4 zeros. When there is no clock pulse applied, initially all the flip-flop outputs are zeros. Now, here you are having QB XNOR QD. QB XNOR QD. So, here both the bits are same. So, that means the serial input is 1. See, here if you observe, shift register is the sequential circuit, whereas this XNOR gate is what? Just logic gate, or you can say it is a combination circuit. Yeah, thank you Vijay Agarwal. See, here you are having XNOR gate. XNOR gate. XNOR gate, the moment if you are giving the inputs, based on the input combination, it will produce the corresponding output immediately. It no need to wait for the clock signal, right? Because here shift register inside, you are having flip-flops. So, whenever you are given the clock signal positive edge, then only based on that, here output will get shift. Whereas here, the moment if you are having some inputs, because it is combination circuit, the moment based on the combination of inputs here you are having, accordingly it will produce the output, right? So, that means before you are applying the positive edge of the clock signal, since you are having all the 4 bits are zeros, here serial input is QB XNOR QD, so 0 XNOR 0 is nothing but 1, 1, okay. Now, first time positive edge of the clock pulse I am applying. First time positive edge of the clock pulse I am applying. Now, what will happen? These 4 bits will get right shift. These 4 bits will get right shift. So, here 1, 0, 0, 0. Now, 0 XNOR 0 is nothing but 1. Now, second time positive edge of the clock pulse I am applying, right? So, these 4 bits will get right shift. 1, 1, 0. Now, 1 XNOR 0, these two are different, so that means here you will get 0. Now, third time positive edge of the clock pulse I am applying. In this case, you will get 0, 1, 1, 0. Now, once again 1 XNOR 0, you will get 0. Fourth clock pulse I am applying. You will get 0, 0, 1, 1. Now, once again 0 XNOR 1, 0 you will get. Fifth time I am applying positive edge of the clock pulse. So, here I will get 0, 0, 1. Now, once again 0 XNOR 1. So, output is 0. Sixth time positive edge of the clock pulse I am applying. So, here we are getting all the bits are zeros. See, just observe here. According to the given question, we have assumed the initial state as 4 zeros. Okay. Now, we are getting the same state, 4 zeros. After applying what? Sixth time positive edge of the clock pulse. After applying sixth time positive edge of the clock signal, in between, these are the states you are getting. 1, 0, 0, 1, 1, 0, like that. Okay. Now, if you apply 7th clock pulse, this state you will get. 8th clock pulse, this one. 9th clock pulse, 10th, 11th. Once again, 12th means same, right? So, that means what is happening here? These are the finite number of states. This particular circuit is repeating, right? So, that's why we will call this overall circuit as counter, right? So, that means the application of shift register is nothing but counter, you can say. Okay, basic application is it is performing shifting operation. So, according to the name shift register we have given, but when you are giving the serial input, instead of externally from your side, if you are giving with the help of some logic gates or some through feedback mechanism, right? If this particular circuit is repeating the entire operation, right? So, then we will call this overall circuit as counter. Okay, right. Now, in this question what they have asked, this particular overall circuit will not produce which state? Okay. So, here you are having 0001, 0001, yes, we are getting here, 0001 we are getting here, then 0011, yes, we are getting 0011, next 1100, 1100 also we got, okay. Now, here option D they have given 1110, 1110, 1110 you don't have, 1100 you are having, but 1110 you don't have, right? So, that means that is the correct option for this question. Here the question is will not be produced. So, obviously among the 4 choices, option A, option C, option B, option A, option B, option C, these are the states this particular circuit is producing, whereas the state which is mentioned in option D is not produced, is never produced by this particular circuit, right? So this is the MCQ. So that's why the correct answer for this question is option D. Suppose if they want, they can make the same question as MSQ. Okay, instead of will not, if they mention which of the following states will be produced by the above configuration. If you are supposed to, like, here the question will be like this: identify the states which are produced by this particular configuration. In that case, which options you will choose? Instead of MCQ, if they ask MSQ, and here the question is identify the states which are produced by the above configuration. Yes, very good, Saptak. Yes, obviously you have to choose A, B, C, because in this question you are having A, B, C, all are correct. Okay, these are the three states are producing by this particular counter configuration, right? Yes. So in this way, based on the given type of the question and based on the wording of the question, right, you have to choose the correct option carefully, right? Related to MCQ, related to MSQ, okay, always read the question carefully and choose the answer according to the given question, okay, right. Next question, it is MSQ. That means either one option or more than one option can be correct. Here they have given one circuit, and what they are asking, see here in this question they have given the initial state 011. It is not 000. Okay, whenever they specify other than zeros, you have to assume the same state. Okay, so if you are assuming this is the initial state, then which of the following states will never be produced by the above counter during its entire operation? Just like the previous circuit, here they have given one counter circuit, and they are asking here also among these four choices, okay, which state this particular counter never produce. Here this is Q naught bar, this Q naught bar. Yeah, still time is there, you can try. Yeah, I will disclose the correct answer after some time. All of you well tried. See, first I will solve this question one method. Here they have given the initial state Q2, Q1, Q0 equal to 0, 1. Q2, Q1, Q0 equal to 0, 1 they have given. Now just observe. See, here whenever you are solving any question related to sequence circuit, okay, especially when you're having more than one flip-flop, okay, whenever you're having more than one flip-flop, just observe the first point is whether for all the flip-flops you're having the same common clock signal or different clock signal. That is the first observation point. Whenever more than one flip-flop you're having, just observe the clock signal. Here in this case, you're having D flip-flop, JK flip-flop, T flip-flop. For all the three flip-flops, the clock signal is same. The clock signal is same, right? So here they have mentioned positive edge trigger. So that means whenever clock signal changes from 0 to 1. Whenever clock signal changes from 0 to 1, based on the input, accordingly your output will get affected. Okay. So since the clock signal is same for all the three flip-flops, so this particular circuit is nothing but what? Synchronous sequential circuit. Synchronous sequential circuit. Synchronous sequential circuit. If you are having for different flip-flops, if you are having different clock signal, then it is asynchronous because all the flip-flops are not having the same clock signal. Okay, but in this case, all the flip-flops are having the same clock signal. So that means for each flip-flop, output will be affected with respect to your external clock signal, positive edge of the clock signal at the same time. That's why we are calling it as synchronous circuit. Okay, right. That is your first observation point. And then just observe here. Here you are having D flip-flop. Okay, here D2 is nothing but what? D2 is nothing but this Q1 bar. Yes or no? This Q1 bar we are giving as the D input here. Q1 bar as the D input for this flip-flop. Okay, now, so this is D flip-flop, you know. Okay, directly they have mentioned it is a D flip-flop. Now just carefully observe. Here is the magic is there. Just observe. Here they have given JK flip-flop. Here they have given JK flip-flop. Now tell me, J1 is nothing but Q2. J1 is nothing but Q2 and K1 is nothing but Q2 bar. K1 is nothing but Q2 bar. So that means J and K inputs are what? Complement each other. When J and K inputs are complement each other, JK flip-flop becomes which flip-flop? All of you please respond. Here J input, K input, both are complement each other. Then JK flip-flop will become which flip-flop? Yeah, Kundan, no. We already discussed, right? Here JK inputs are complement. See here, J and K inputs are complement. Then what you are getting? D flip-flop. If X equal to D, then it is D flip-flop, right? Yes, very good. Very good, Saptak. Very good, Revant. Yes, very good, Kundan. Yes. Here J and K inputs are complement each other. So that means this particular flip-flop, even though they have mentioned it is a JK, but now this overall configuration is nothing but simply D flip-flop. Simply D flip-flop. Because J and K inputs are complement each other. Okay, right. So whatever the D input you are having, that will come here. Okay, since it is a D flip-flop, your next state is nothing but D input. Your next state is nothing but D input. So here the J input only will come. Okay, right. Now just carefully observe. See, forget about this circuit for the time being. Just observe only this configuration. Here you are having one D flip-flop. Here you are having one D flip-flop. Output of this stage we are giving as the serial input. Okay, and here this complemented output of this D flip-flop we are giving as a serial input. Now can you identify up to here, your whatever the configuration you are having, can you identify what is the name of this counter without using pen and paper? Can you identify? You are having two D flip-flops. the output of one stage we have given as serial input for other stage, and the second stage complement output we have given as serial input. Can you guess? Can you guess this overall circuit? What is this Paddy counter? With the help of D flip-flops, you have studied two counters. Right, very good, Kundan, very good. It is a Johnson counter. Yes, very good. Since you are having two flip-flops, it is the 2-bit Johnson counter. 2-bit Johnson counter. 2-bit Johnson counter. See, instead of complement output, if the normal output, if they have given as serial input, then it is a ring counter. Then it is a ring counter. Yes, very good, Revan, very good. Okay. Whenever complement output of the last stage D flip-flop, if you are giving us serial input, then that particular overall circuit is nothing but Johnson counter. Okay. The other name for this one is twisted ring counter. Okay. See, if you are giving directly the normal output, then it is a ring counter. But instead of that, if you are taking complement, so that means if this is 0, this will be 1, or if this is 1, this will be 0. So because of that, the other name for this one is twisted ring counter. Okay, right. Now for the timing, let us focus up to here. So for these two flip-flop, clock is same. So just like the previously shift register, how we have solved, in the same procedure I am following. First column is clock pulse number. That means postage of the clock pulse numbering. First time, second time, third time, like that. Okay. Now here you are having two D flip-flops. Okay. 2 D flip-flops. So for easy understanding, I will explain here. So here in this case, D2, if you consider this overall circuit as like shift register, okay, 2-bit shift register. So here this D2 is nothing but Q1 bar. D2 is nothing but your serial input, you can say. D2 equal to Q1 bar. And then here directly I am writing first stage output is Q2 and second stage output is Q1. Okay, in the question just focus carefully. For the timing, I am focusing with respect to first 2 bits. Here Q2, initially when there is no clock pulse applied, Q2, Q1 they have given as 0, 1. Okay, right. Now here Q1 bar will become 0. Because Q1 value is 1, the corresponding complement is 0. See, this per day configuration, forget about this feedback path. If they don't give this feedback path, this configuration is nothing but shift register. Okay, because output of one stage D flip-flop, you are giving as serial input for other stage. So that is nothing but 2-bit shift register, right? So for this overall shift register, the serial input you are giving as the complement output of this stage, right? So previously we have discussed 4-bit shift register. Now this is the 2-bit shift register. But here the serial input is this one. Q1 bar is the serial input. Okay. Now first time postage of the clock pulse I am applying. So in that case, these 2 bits will get right shift 0, 0. Now Q1 bar is nothing but 1. Now second time postage of the clock pulse, these 2 bits will get right shift 1, 0. Now 0 bar is 1. Now third time postage of the clock pulse, these 2 bits will get right shift. You will get 1, 1. Complement of 1 is 0. Fourth time if you are applying postage of the clock pulse, what will happen? These 2 bits will get right shift. So you will get 0, 1. Okay. Now if you observe carefully, initially we have assumed 0, 1. You are getting the same state. You are getting the same state after applying the fourth clock pulse. Yeah, Jagdish, you can ask that query at the last. Okay, I will discuss. Okay. So just observe here, you are having initial state as 0, 1, then 0, 0, then 1, 0, then 1, 1. Okay, these are the 4 states you are having. Okay. So this particular counter, if you apply further clock pulses like 5th clock pulse, you will get 0, 0, 6th clock pulse 1, 0, 7th clock pulse 1, 1, like that. So that means only these 4 states will get repeat. That's why whenever you are having a shift register, for that particular shift register, instead of giving input externally from your side, through some feedback mechanism or with the help of some logic gates, if you are giving the serial input, then that particular shift register will repeat good number of states. Because it is repeating number of states repeatedly, we can call that overall circuit as counter. Okay, since you have connected the complement output of last stage as serial input, this per day counter is nothing but Johnson counter, right? Okay, so this is the 2-bit Johnson counter. So up to here we got, this is the tabular form. Okay, now let us proceed further. Just carefully observe and tell me. Here you are having T0. This T0 is nothing but what? The output of this XNOR gate. Now, for this XNOR gate, you are having two inputs. One input is Q1, other input is Q1 bar. Now, always these two will be complement each other. Say for example, if this is 0, this will be 1, or if this is 1, this will be 0, right? So, always you will get 0, 1 or 1, 0 at the input side. Now tell me, for a 2-input XNOR gate, if the input bits are complement to each other, if the input bits are not same, then what is the output you are going to get? Without using pen and paper, can you tell? We have discussed already in the yesterday class also. Yes, very good Saptak. Here, whenever the inputs are not same, okay, for 2-bit case, you will get the XNOR gate output as 0. Okay, if both the inputs are same, then you will get 1. If both are zeros or both are 1, then you will get 1. Because these two are complement to each other always. Throughout the overall circuit operation, here always T value is 0. Okay, now regarding T flip-flop, just write the characteristic equation. Q of T plus 1 equal to T XOR Q of T. But here in this case, you got T value as 0. Just substitute here 0 XOR Q. What you will get? All of you quickly do and tell me. 0 XOR Q. Yeah, very good Saptak. Yeah, Revant, you can cross check. See, just apply A XOR B formula, right? A bar into B. A bar into B plus A into B bar. See, 0 bar is nothing but 1. 1 into Q is nothing but Q. Here 0 into anything is 0. When you are adding 0 to anything, resultant value will remain same. Right? Yes, very good Savik. Yes, very good Revant. So that means it is very simple. Previously we got to know that whenever T value is 1, your next state is always complement of previous state. Now, here you are learning one more point. For a T flip-flop, whenever T value is 0, your output will remain same. Whatever the earlier state you are having, it will remain in the same state. Okay. Now, according to the given question, the initial state they have given, right? So according to this, your Q0 value is what? 1. So that means throughout this operation, here I am considering Q0 as one more column. Okay, right. So throughout the operation, here Q0 value will remain at 1. I hope it is clear for everyone. Okay. So whenever you are having the circuit diagram with the help of multiple flip-flops, so just observe flip-flop by flip-flop and then just do the analysis like this. Okay, so that you will get the answer quickly and you will get the correct answer also. Okay, both are important, right? So whenever you are attempting the competitive exams like GATE, okay, so the accuracy is important, speed is also important. Both are important. Okay, I hope it is clear for everyone. Now this overall circuit is going to produce these 4 states. Yes or no? 0, 1, 1, then 0, 0, 1, 1, 0, 1 and 1, 1, 1. Okay, so these are the 4 states this Paddy counter will repeat. Okay, now just observe here. Here you are having 0, 0, 0, 0 we don't have here. Next 0, 1, 0, 0, 1, 0 we don't have. Next 1, 0, 0, 1, 0, 0 also we don't have. We are having 1, 0, 1. Okay. Next 1, 1, 0. 1, 1, 0 also we don't have. We are having 1, 1, 1, right? So that means here this circuit is not producing these 4 states. Never will produce these 4 states, right? So according to the given question, since it is MSQ, all the 4 options are correct. All the 4 options are correct. So all of you quickly respond. Is it clear for everyone how we got all the 4 options as correct? So all of you quickly respond. Yes, very good, very good. Okay. Now here I have explained this question in one method step by step, okay, for understanding purpose. Okay. Now the same question, now I will discuss one more method without using pen and paper. Without using pen and paper, you will get directly the answer. It will take only couple of seconds. It won't take even more than 1 minute. It will be less than 1 minute only without using pen and paper. Okay. It may take hardly 30 seconds. That's all. Okay. Without using pen and paper, you can answer the same question. If you read the question carefully and if you observe the given circuit carefully, then it won't take more than 30 seconds for solving this question. But for understanding purpose, I explained completely step by step. Okay. Now I will discuss the second method. Okay. So they have given one circuit diagram and they have given the initial state like this. And here they are asking this particular circuit never produce among these states, among these 4 states, which of the states this particular circuit never produce. This is the question, right? Now just focus only this particular circuit last stage flip-flop. Only focus the last stage flip-flop. Okay. So the last stage you are having T flip-flop. This is the T flip-flop. Okay. So T0 is nothing but output of this XNOR gate. So for this XNOR gate, you are having Q1 as one input and Q1 bar as another input. Since these two inputs are always complement to each other, since these 2 bits are not equal always, obviously XNOR gate will produce always the output as 0. Since T value is 0, when you substitute in the characteristic equation, you will get Q of T plus 1 equal to Q of T. Even from truth table also you might have studied. Okay. Whenever T equal to 0, your next state will remain in the same state. Okay. Whenever T equal to 1, Q of T plus 1 will be complement of the previous state, like that. Okay. Now just if you focus only this flip-flop, you got Q of T plus 1 equal to Q of T. So that means in the given question, Q0 value they have mentioned 1. Right? So that means this overall circuit during its entire operation, Q0 value will remain 1. This is the must and should. Yes or no? This is the must and should. When this is the must and should, just focus only the Q0 value in all the 4 choices. When this is must and should during its entire operation, now just focus in all the 4 choices Q0 value. Here you don't have even single choice Q0 value as 1, right? Obviously all the 4 choices will be correct. How many of you liked this method? How many of you understood this method without using pen and paper? You can answer like these questions in less than 30 seconds. Once if you are clear about all the flip-flops characteristic equation and if you read the question carefully, then it won't take much time. So all of you respond. How many of you liked this question? All of you quickly respond. How many of you felt that this question is very interesting? Yes, very good, Revant, Saptak. Yes, very good, Kundan. Yeah, Savik. Yes, very good. See here, I already explained previously that Here when Q1 bar both are complement, you got t value 0. So when you substitute here, final equation you got, your next state is nothing but same as present state, right? Yes, thank you Kundan, thank you. Yeah, so your next state is same as present state. Okay, so whatever may be the circuit they have given, okay, when you have observed that the last flip-flop always its output remains same because its t value is 0. Savik, up to this point, is it clear or not? Throughout the operation, whatever might be happening here, forget about. Okay, forget about whatever might be happening here. Throughout the operation, since t value remains 0, your next state of this particular flip-flop will remain at the previous state. Yes, thank you Manoj. Savik, is it clear up to this point? Here, this particular flip-flop output will remain in the previous state only, will remain in the same state only throughout the operation. Yes, very good. Now, just observe the given question. In the given question, you're having since you're having three flip-flops, the outputs are Q2, Q1, Q0. Regarding that, they have given initial state as 0, 1, 1. 0, 1, 1. So that means here Q0 is correspond to this particular one, right? So throughout the operation, here this particular flip-flop output will be 1, okay. Now just observe all the 4 choices Q0 value only. Here when you're having 3 bits, the last bit is correspond to Q0, okay. Just focus only the last bit. The first bit is correspond to Q2, second bit is correspond to Q1, and the last bit is correspond to Q0, okay. So in all the 4 choices, you're having 0, 0. That means 0, this particular circuit never produce the last stage output as 0, right? Since the question is this particular given circuit will never produce among these 4 states which are, okay, all the 4 states never produced by this particular circuit. I hope it is clear now, Savik. Okay, right. We'll proceed to the next question. This is the NET, that means answer will be a number. Here the question is, if the clear input is synchronous, then the mod value of the following counter will be. Here they have given JK flip-flops, and for all the JK flip-flops you are having input value as 1. For all the JK flip-flops, the value is 1, and here the output of this AND gate they have given as what? Clear input for all the flip-flops. Clear input for all the flip-flops. I hope the image is visible for all of you. If you are having regarding any notation, if you are having any doubt, you can ask. I will mention here. The first stage is Q0 output, second stage Q1, third stage Q2, and last stage is Q3 output. And for all the flip-flops, you are having two outputs, Q0, both are complement. Here normal, here complement, like that. Yes, very good, Savik. Yes, very good, Manoj. So all of you give a try. Yeah, whatever the answer you are getting, you can mention in the chart. Okay, I will discuss. This is a very interesting question. I will disclose the answer after some time. So for this question, you can assume initial state you can assume all the bits are zeros. You can assume initial state as all the bits are zeros. With that assumption, you can do this question. Yeah, all of you other students also please reply. All of you are well trying. Okay, I will disclose the correct answer after some time. Sorry, here this is not LSB, Q0 is LSB. That is a typo mistake. Now you can correct it. Here Q3 is the MSB and Q0 is LSB. This is typo mistake. Okay, this is not Q1 will be intermediate bit. Okay, Q3 is the MSB and Q0 is LSB. Here Q0 is the LSB. Yes, very good, Kundan, very good. Yes, 5 is the correct answer. 5 is the correct answer. See, just focus this particular circuit. You are having JK flip-flops. All the flip-flops are JK only. And for all the flip-flops, J and K inputs are equal to 1. J and K inputs are equal to 1. Okay, if J and K inputs are same, that means JK flip-flop will become T flip-flop. Okay, if JK inputs are same, then JK flip-flop will become T flip-flop. And if T value is 1, then what will be the characteristic equation of T flip-flop? Even though they have given JK flip-flops, but since J and K inputs are same, all these flip-flops are nothing but simply T flip-flops. Simply T flip-flops. Now, for a T flip-flop, if T value is 1, what will be the output? What will be Q of T plus 1? See, previously we have discussed if T value is 1, Q of T plus 1 equal to Q of T bar. If T equal to 1, Q of T plus 1 equal to Q of T bar. If T equal to 0, it will remain in the same state. If T equal to 1, the next output will be complement of present output or previous output, like that. Okay, this will happen according to the respective flip-flop, whatever the edge of the clock signal you are giving. Okay, that is very important. Okay, see, whenever T value is 1, the output will be, the next state will be complement of present state. That is true, but that will happen for the respective flip-flop whenever you are getting the corresponding edge of the clock signal, right? Now just tell me, here you are having 4 T flip-flops, whether all the 4 T flip-flops are having the same clock signal or different clock signals. Whether all the flip-flops are having the same common clock signal or different. Yes, you are having different clock signal, right? Just observe here, for the first flip-flop we are giving external clock signal, whereas second flip-flop, the output of this stage we are giving, for this flip-flop, output of this stage we are giving, for this flip-flop, output of this stage we are giving, right? Yes, very good, Kundan, very good. Yes, very good, Anuradha. So, as I already mentioned, whenever you are getting any sequence circuit which contains more than one flip-flop, the first observation point, whether all the flip-flops are having the same common clock signal or different. That is first observation. Okay. Previous questions we have discussed with the help of all the flip-flops are having the same clock signal. So those circuits are the examples for synchronous, and this is the circuit is an example for asynchronous. Asynchronous sequential circuit. Okay, this circuit is an example of asynchronous sequence circuit, and here this particular circuit will repeat good number of states. So accordingly we will give the name of this circuit as counter, asynchronous counter. Okay, and one more point, here the output of one stage we are giving as clock signal for other stage. Okay, so this particular phenomena is called, can you guess? Output of one stage we are giving as clock signal for other stage. You might have studied in binary adder also, 4-bit parallel adder, or the other name for that one. From there you will get the hint, the other name for this particular counter. Yes, very good, Kundan. It is the ripple. Okay, there we have mentioned ripple carry adder. Okay, the carry output of one stage full adder, we used to give carry input for next stage. Right, very good, very good, very good Kundan, Savik, Saptak. Yes, very good, Revant. In the same way, here we are giving the output of one stage as a clock signal for other stage. So this particular phenomena is called ripple phenomena. So accordingly, the other name for this one is ripple counter. Ripple counter, asynchronous counter or ripple counter. Whenever they mention ripple counter, that means it is a asynchronous counter. Okay, right. Now carefully observe. Forget about this circuit. Okay, forget about this circuit and forget about this logic gate also. Regarding this logic gate, clear input we'll discuss after some time. For the timing, if you don't have all these three flip-flops, if you're having only this flip-flop, since t value is 1, your Q0 will get complement when? What is the condition? Here clock signal, you're having negative edge, bubble is there. Okay, here bubble is there. So that means whenever external clock signal changes from 1 to 0, whenever external clock signal changes from 1 to 0, that time only here Q0 will get complement because t value is 1. Because t value is 1. Okay. Now, forget about this part, forget about this part. If you are having only this second flip-flop, if you are having only this flip-flop, for this particular flip-flop, Q0 is the clock signal, Q0 is the clock signal, and since you are having bubble here, whenever Q0 changes from 1 to 0, whenever Q0 changes from 1 to 0, that time only, since you are having t value 1, here output will get complement. Okay. All of you please respond up to this point. Is it clear or not? Up to this point, whatever I have told regarding first flip-flop and second flip-flop, is it clear or not? If you are having any doubt, you can mention. I will repeat once again. Yes, clear. Very good, very good. Now, just remove the first two flip-flops and remove the last flip-flop. You are having only this flip-flop. Okay, if you are having only this flip-flop, for this particular flip-flop, the clock signal you are getting from Q1, and since you are having bubble here, whenever Q1 changes from 1 to 0, whenever Q1 changes from 1 to 0, since you are having t value 1, here output will get complement. Okay, similarly, just remove all these three flip-flops. You are having only this flip-flop. Okay, now, in order to get complement, since you are having t value 1, output will get complement, but when it is, whenever Q2 changes from 1 to 0. Whenever Q2 changes from 1 to 0. I hope it is clear for everyone. Okay, in this particular circuit, all the flip-flops are not having the same clock signal. Okay, each and every flip-flop is having different clock signal. Okay, but since they have mentioned bubbles, whenever bubble is there, negative edge. If bubble is not there, it is a positive edge. Okay, whenever the respective edge of the clock signal come, then only, even though t value is 1, all the flip-flop outputs won't complement for each and every external negative edge of the clock signal, because here clock signals are different. I hope up to this point it is clear for everyone. Once if it is clear, now let us follow the same approach. Whatever the shift register or earlier counter we have discussed, follow the same approach. Tabular form method only we will solve. So the first column is clock pulse numbering. Here in this circuit, since they have mentioned negative edge, so I am considering the first column as negative edge of the clock pulse numbering. Okay, and then here you are having 4 outputs. I am just mentioning those 4 outputs: Q0, Q1, Q2, Q3. These are the 4 outputs we are having. And now just focus about this particular AND gate. For this AND gate, we are having Q2 as one input, and other input is Q3 bar. Okay, now since you are having AND gate, okay, and here there are no bubbles. Okay, it is direct signal. That means whenever this AND gate output is 1, that time for all the flip-flops you will get clear input as 1. Okay, now all of you please respond. In order to get output of AND gate as 1, what is the condition for Q2 and Q3 bar? Or you can say, like, what is the value of Q3 and what is the value of Q2? It should be, in order to get output of AND gate as 1. All of you please respond. Yes, Q3 is the MSB and Q0 is the LSB. Here you are having AND gate, inputs are Q2, Q3 bar. In order to get output as 1, what should be the Q3 value? What should be the Q2 value? All of you please respond. Yes, very good. Very good, Kundan, Saptak. Yes, very good. Here just observe. Here for an AND gate, in general, if you are having the normal inputs, if both the inputs are 1, then only output is 1. Here Q2 is the normal, so that means it is 1. But here you are having Q3 bar. Okay. If Q3 is 0, then complement of 0 is nothing but 1. So then in that case, both the inputs are 1, output of AND gate is 1. Okay, right. Now just focus here. Initially, when there is no clock pulse applied, we have assumed that initial state as 4 zeros. 4 zeros. Okay. Now, first time I am giving external negative edge of the clock signal. Okay. So, for this particular flip-flop, T value is 1 and you are giving the negative edge of the clock signal. Yes. So, that means Q0 will be complemented. Q0, earlier you are having 0, now it will become 1. Okay. Now, just observe. Here, for this particular flip-flop, Q0 should change 1 to 0. Okay, but here Q0 is changing from 0 to 1. So that means this particular flip-flop output will remain in the same state. Output will remain in the same state. Now regarding Q1 there is no change. Obviously Q2 will remain same. Here Q2 no change. Q3 will remain same. Okay, you will get clarity. I will explain step by step. Just 1 second. Okay. Now I am giving the second time negative edge of the clock signal. Second time negative edge of the clock signal. So this flip-flop output will get complement. Obviously. Okay. Now just focus. Here in this case, Q0 is changing from 1 to 0. Yes, Q0 is changing from 1 to 0. So that means this particular flip-flop is getting negative edge of the Q0 signal. Right. So now tell me, in this case, Q1 whether it will get complement or not. Now tell me what will be the Q1 output. See, since you are having T value 1, output will get complement. When, what is the condition? Here, whenever Q0 changes from 1 to 0. Yes, since Q0 value changes from 1 to 0, here Q1 will be complemented. Q1 will be complemented, right? Very good, Kundan. Here Q1 is changing from 0 to 1, but your requirement is Q1 should change from 1 to 0. Okay, so since you are not getting the respective edge, so here Q2 will remain same and here no change, here Q3 will remain same. Now, third time negative edge of the clock signal we are applying. Here this will complement. It is a positive edge, so it will remain same. Here there is no change, it will remain same. No change, it will remain same. Now, fourth time negative edge of the clock signal I am applying. Here it will be 0. It will be 0. Now, here Q0 is changing from 1 to 0. Yes, this particular flip-flop is getting the negative edge of Q0 signal. So, Q1 will be complemented. Q1 will be complemented. Now, carefully observe. Q1 first time changing from 1 to 0. Q1 first time changing from 1 to 0. So, that means Q2 will be complemented. Q2 will be complemented. Now, here it is a positive edge. So, it will remain same. It will remain same. Up to here, is it clear for everyone? In this way, we have to analyze step by step. Okay. Whatever the first flip-flop you are having, that particular flip-flop output always will get complement whenever you are sending external clock signal. Whereas this particular flip-flop output will get complement whenever Q0 changes from 1 to 0. Similarly, for this particular flip-flop. Similarly, for this, like that. Okay. I hope it is clear for everyone. Now, in the question they have mentioned that, if the clear input is synchronous. Okay. For the time being, let us assume the other case. See, just observe. Here, I have applied fourth time negative edge of the clock signal. Okay. When you have applied fourth time negative edge of the clock signal, you got Q0, Q1, Q2, Q3 as 0, 0, 1, 0. 0, 0, 1, 0. Right? Yes, Saptak. See, tabular form up to which row you understood? Saptak, up to which clock pulse number you understood? Just mention the row number. Up to second row you understood. Okay, fine. Now, okay. Now second time positive edge of the clock, second time negative edge of the clock signal I have applied. Okay. So whenever you are giving external negative edge clock signal, obviously this flip-flop output will get complement because T value is 1. T value is 1. Now just focus. For this particular flip-flop, the clock signal is Q0. If it changes from 1 to 0, then since you are having input as 1, T value 1, so output will get complement, right? So now observe here, when you have applied second time negative edge of the clock signal, Q0 becomes 0. Now Q0 is changing from 1 to 0. Q0 earlier value is 1, now its value is 0. That means you are getting 1 to 0 transition, right? So that means this particular flip-flop is getting negative edge of the clock signal. Since T value is 1, output will get complement. So 0 becomes 1. 0 becomes 1. Okay, next. Here for this particular flip-flop, Q1 should change 1 to 0. But here Q1 is changing from 0 to 1. So here Q2 will remain same. Whatever earlier state you are having, it will remain same. And regarding Q2, there is no change. So obviously here you require negative edge. Okay. So that means the Q3 output will remain same. Whatever the earlier state you are having, it will be in the same state. Up to this second row, is it clear, Saptak? Yes, very good. Now third time negative edge of the clock signal I am applying. Obviously the first state output will get complement. That means 0 is becoming 1. In this case 0 to 1. But here requirement is 1 to 0. So this output will remain same. This output will remain same. Here there is no change. This output will remain same. Here there is no change. This output will remain same. Okay. Now fourth time negative edge of the clock signal I am applying. This output become complement. 1 becomes 0. Now, yes. For this flip-flop, you require Q0 changes from 1 to 0. Yes, that is happening here. 1 to 0. Since this particular flip-flop is getting negative edge, since you are having T value 1, output will get complement, right? So that means here 1 becomes 0. 1 becomes 0. Now, for this particular flip-flop, you require Q1 should change from 1 to 0. Yes, Q1 first time it is changing from 1 to 0. Because it is changing from 1 to 0, since you are having T value 1, your output of this flip-flop will get complement. So that means 0 become 1. Here 0 to 1 transition happening, but here requirement is 1 to 0. So that's why here Q3 output will remain same. I hope it is clear now. Right. So here if you observe, you are getting Q3 as 0. Yes, Q3 as 0 and Q2 as 1. Yes, we are getting this combination. Okay. After applying fourth time negative edge of the clock signal, you got the state like this. According to our requirement, in order to get AND gate output as 1, the respective Q3, Q2 values, we are getting here 0, 1, 0, 1. Just observe, here you are having AND gate. The moment you are getting this combination 0, 1, okay, the moment you are getting 0, 1, the output you will get 1. Output you will get 1 because it is a combinational circuit. Okay. The moment if you are changing the input combination, accordingly your output will be affected. Okay, in the same way, here for all the flip-flops, if you consider the clear input is asynchronous, okay, if the clear input is asynchronous, then what will happen? The moment you got here 0, 1, because of that here AND gate output is 1. The moment you are getting AND gate output as 1, all the flip-flops clear input as 1. Okay, it's like reset. Okay, the moment you are clicking on reset button, all the flip-flops will be initialized. In the same way here, all the flip-flop outputs will be cleared. Okay, all the flip-flop outputs will be cleared. This will happen if the clear input is asynchronous. If the clear input is asynchronous. See, asynchronous means it is very simple, very simple. Just like for a logic gate, the moment if you are getting a particular combination, based on that it will produce the output. In the same way, for all the flip-flops, if the clear input is asynchronous, it don't require any clock signal. The moment if the clear input is active, because of that, all the flip-flop outputs will be cleared, right? So that means here what will happen? 0 to, see, consider Q3 is MSB and Q0 is LSB. Okay, so just write the corresponding decimal equivalent. You have to see from right to left. Okay, Q3 is MSB and Q0 is LSB. So you're having 0, then 1, then 2, then 3. So that means these are the 4 states this particular counter will repeat. Okay, if you continue further, only these 4 states will repeat. Okay, so 0 to 3. If the clear input is asynchronous, then the counter will repeat 0 to 3, only those 4 states. That means since you are having 4 different states, 0, 1, 2, 3, 4 different states, the mod value of this counter will be mod 4 counter. Mod 4 counter. I hope it is clear for everyone up to this point. Now, but in the question they have mentioned that the clear input is synchronous. The clear input is synchronous. Synchronous means, see, just like here, just if you observe, for all the JK flip-flops, J and K value are equal and equal to 1. So that means for a T flip-flop, for all the 4 T flip-flops, even though you are having T value 1, your output becoming updated, whenever you are getting respect to negative edge of the clock signal, right? So that means what? Whatever the inputs you are giving to the flip-flops, those are called synchronous inputs. In the same way, here this clear input, if it is synchronous, if the clear input is synchronous, then what will happen? See, you might have got, after applying 4th clock pulse, you got Q3, Q2 combination as 0, 1. Because of that, AND gate output is 1. Even though AND gate output is 1, all the flip-flops are getting clear input as 1. But when all the flip-flop outputs will be cleared, if the clear input is synchronous, even though all the clear inputs of all the flip-flops are 1, you are getting after applying 4th clock pulse, but actually when all the flip-flop outputs will become 0. See, you have to apply the next clock signal, just like here. See, you are having JK flip-flop, here you are having value as 1. Okay, so whenever you are applying the next stage of the clock signal, that time only your output is affected. Okay, in the same way, here for overall circuit, since you got clear input as 1, so you have to apply the next negative edge of the clock signal. Then what will happen? Here this particular counter, this state will count. Okay, after applying 5th time negative edge of the clock signal, then only all the flip-flop outputs become 0. Okay, right. So if the clear input is synchronous, then what will happen? This counter will count that particular state. Earlier state it will count. After that, when you are applying the next clock signal, that time only all the flip-flop outputs will become 0. Right. So if the clear input is synchronous, then it is going to count 0 to 4. This is 4. 0 to 4. So since it is having 5 different states, so the counter value, mod value will be 5. It is mod 5 counter. See, whether they will give overall circuit as asynchronous or overall circuit as synchronous, okay, forget about that. Regarding clear input, okay, if the clear input is asynchronous, the moment clear input is 1, you no need to supply the next clock pulse. Okay, all the flip-flop outputs will become 0. Okay, whereas if the clear input is synchronous, you have to apply the next clock signal. That's all. Simple logic. Whether it is asynchronous counter or synchronous counter, okay, regarding clear input, based on this the answer will vary. Okay, whether in the question if they mention asynchronous, you will get one answer. If they mention synchronous, then you will get one more answer. So this is very, very important. So that means the final answer for this question is mod 5. Here they have asked only the mod value, so the final answer will be 5. Okay, right. Next question, this is the MCQ, that means only one option will be correct. So all of you read the question and attempt this question. This is a simple question. This is a question based on 2 chapters. Currently, we are solving the questions on 5th chapter. Okay, and if you observe the choices, you are having number system. Okay, so that's why I told that once if you are strong on the initial chapters, then only you can answer the upcoming chapter questions. Whenever they frame the question based on the 2 different chapters of the same subject. Okay, if you don't know the basics of the first chapter, then if they frame the question like this, you may answer up to, okay, in your solution you will get up to some stage, you will get correct, but you cannot attempt among the given choices which one is correct. So that's why it is very important for all the 4 branches, whether you are from EC or electrical, instrumentation or computer science. Okay, irrespective of the branch, all the 4 branch students, okay, the first 5 chapters are very, very important. Once if you master the first 5 chapters of digital circuit subject, you can score well in your coming GATE exam. Other students also please try. I will mention the correct answer in some time. Still we are having 38 seconds. So other students also please try. Yeah, well tried, Revant. Yes, very good, Kundan. Very good. Option B is the correct one. Option B is the correct one. See here, first read the question. You're having, they have mentioned 3 letters P, Q, R are regarding what? Number of unused states. Unused states in 3-bit ring counter, 4-bit Johnson counter and mod 10 counter respectively. Then the value of P plus Q plus R, they are asking the equivalent value in base 5 they have given 2 choices, in base 10 they have given 2 choices. Okay, first recall. See, when you're having 3-bit ring counter, how many states you will get in a 3-bit ring counter? The number of used states, how many? Yes, number of states you have used only 3. Because you are having 3 D flip-flops, the normal output of the last stage you will give as serial input, right? So that means how many number of flip-flops you are having, that many states you will get. So in the ring counter, the number of bits, number of D flip-flops, number of states, all are same. So in the ring counter, you will get whatever the number of bits they will specify, the same number of states you will get. So here they have mentioned 3. So obviously here the number of used states will be 3. Okay, but in general, when you are having 3 bits, if you write in terms of zeros and ones, total how many combinations you will get when you are having 3 bits? Yes, you will get total 8 combinations, right? So that means the total number of states possible is 2 power 3, that is nothing but 8. But out of which, with the help of this counter, we are getting only 3 states, right? So that means number of unused states is nothing but, from total number, we have to subtract this number, 8 minus 3, that is equal to 5. So that 5 is nothing but, according to this question, it is P. Okay. Now, in Johnson counter, if you are having 4 bits, then in the Johnson counter, you will get double of the number of states. Okay. So that means 2 into 4, which is nothing but 8. See, in the ring counter, if you are having n bits, you will get n states. Whereas in Johnson counter, whatever the number of bits you are having, just make it double. Okay. That number, if you are doubling, you will get the total number of states. Okay. 2 into 4 is nothing but 8. So here, for a 4-bit number, you will get the total number of states are what? 2 power 4, which is nothing but 16. Okay, from 16 you have to subtract this number. 16 minus 8 is equal to 8. So this is your Q according to the question. Yes, very good, Revant, very good. Now, whenever you are having, for generalized case, you will be having mod n counter. For generalized case, whenever you are having mod n counter, so that means this per day counter will count from 0 to n minus 1. Whatever the number they have specified, that value minus 1. Since you are counting from 0, when you count total number of values, you will get n. So that's why that particular number we will specify. Okay. Say for example here, if you want to specify regarding this ring counter, you can specify this mod value for any counter. Since you are getting 3 states, you can rename this one as mod 3 ring counter. Since you are getting 8 states, you can rename this one as mod 8 Johnson counter, like that. Okay. So here in this case, they have specified 10. So that means that same number of states you will be having. That particular counter will repeat. But when you consider here, since you are starting from 0, the maximum value here it will be 10 minus 1, that is nothing but 9. 10 minus 1 is nothing but 9. See, whether that counter is up counter or down counter, no problem. Okay. Suppose if you are considering up counter, it will start from 0, maximum value will be 9. If it is down counter, means 9 down to 0, like that. But so among these states, 9 is the maximum. For representing 9, how many bits you require? For representing 9, how many bits you require? Yes, obviously require 4, right? 9 is nothing but what? 9 is nothing but 1001. 9 is nothing but 1001. So that means we require 4 bits. We require 4 bits. So just now we have mentioned when you're having 4 bits, total number of states possible is 16. Total number of states possible is 16, out of which with the help of this counter we are using only 10 states. So that means unused states are 6. So this is your R. So now in the question they are asking P plus Q plus R. So just add all of them. P plus Q plus R is equal to 5 plus 8 is 13, 13 plus 6 is 19. So you are getting 19. This is the decimal number. 19 is the decimal number. So here two choices you are having in the decimal form, but no choice is matching. No choice is matching, right? Yes, very good, Apeksha, Saptak, Kundan, Revant. Yes, very good. Now the other two choices you are having base 5 number system. Base 5 number system. Okay. In the first session we have discussed, right, regarding number system conversion. Here you are having the decimal number. Now I want to convert into base 5. We will perform repetitive division with the corresponding base. So that means here 5 3s are 15, remainder is 4, 5 zeros are 0, remainder is 3. So whatever the remainders you are getting, you have to consider in the reverse order while you are placing the digits from left to right. From left to right, while you are placing the last remainder, whatever you got, that will be your first digit, and whatever the remainder you got first, that will be your last. So if you are having any confusion, just cross check whether it is correct or not. 3 4 base 5 you are having, the positional weights will be 5 power 0, 5 power 1. So 5 into 3 is 15, 15 plus 4 is 19. Okay, in that way also you can cross check. Sometime in the exam in hurry, if you write 4 3, say for example, whether it is correct or not, you just cross check with the help of the corresponding decimal equivalent. If you are getting the same answer, your approach is correct. If it is not same, then just reverse it like that. Okay. So the final answer for this question is option B. Option B. Okay. So next question. This is the MSQ. That means either one option or more than one option can be correct. Okay. So here they have given one D flip-flop and a 2x1 mux. So now this question is combination of what? Both combinational circuit and sequential circuit. This is the combination circuit. Mux is the combinational and flip-flop is the sequential. Okay. If you want to broadly classify the entire digital circuits, you can classify as combination circuits and sequence circuits. So this is the question, combination of both combinational and sequential. So all of you give a try. So this is the last question regarding this chapter. So all of you give a try. If you are able to get the correct answer, that means you are excellent. You have understood whatever we were discussing from last 2 sessions and this session. Okay, all of you give a try. Just recall the basics. Yes, very good, excellent, excellent. Kundan and Apeksha. Yes, very good, excellent. Yes, very good, Saptak. Very good, excellent. So all of you definitely will get a very good rank in the coming GATE exam. So this is the question based on both combinational and sequential. The correct answer for this question is both. Options C and D, both are correct. Option C and D both are correct. See here, see whenever you are getting the questions like this, okay, don't get panic in the exam also. Okay, it is very simple. First recall. Whenever you are having flip-flop, I told you that first write the characteristic equation of the given flip-flop. That is the first step. Okay, in the beginning of this session also I have told the same point. Follow the same approach. So here you are having D flip-flop. The given flip-flop is D flip-flop. So Q of t plus 1 will be equal to what? D. Q of t plus 1 equal to D. But here D is nothing but what? The output of this mux. Output of this mux, right? So the output of this mux they have given as a serial input. So here D is nothing but F. D is nothing but F. Now here you are having 2 by 1 mux. You know how to write the standard equation of 2 by 1 mux. Okay. For 2 by 1 mux, the standard equation is, since you are having selection line, single selection line, when it is 0, I0 will be connected, and when it is 1, I1 will be connected. Correct? S bar I0 plus S into I1. Okay. Now according to the circuit, just substitute. Here selection line is A. Selection line is A. Now here I0 is nothing but Q. That means Q of t. Q of t. Here I1 is nothing but Q bar. Q bar. Q bar. Okay, right. So according to the given circuit, we got the simplified expression like this, or equivalent expression like this. Q of t plus 1 equal to A bar into Q plus A into Q bar. Okay, now just observe the choices, what they have mentioned. In 2 choices, okay, just observe here, when Q of t equal to 0, whether we are getting a, in all the 4 choices they are asking next state only, but in 2 choices they are giving Q of t value, in 2 choices they are giving A value. Okay, so for the timing let us verify option by option, because we don't know which option is correct, so better go in the sequence only. Okay, now for the timing I am considering option A. Option A they have mentioned Q of t equal to 0. Okay, Q of t equal to 0. So just substitute here A bar into 0 plus A into 0 bar. A into 0 bar. In the place of Q, you just substitute 0. Now 0 and anything is 0. Here 0 bar is 1. So that means you will get A. But here they have mentioned A bar. So that's why it is wrong. It is wrong. Now let us consider option B. Option B. Q of t plus 1 equal to. Q of t plus 1 equal to. In this case they have given Q of t value as 1. So that means A bar into 1 plus A into 1 bar. Sorry, A into 1 whole bar. Sorry, just 1 second. Yeah. Here A as it is. Here Q value is 1. So that means 1 bar. 1 bar. Okay. 1 bar is nothing but 0. 0 and anything is 0. Right. So you are getting A bar. A bar. But here what they have mentioned? A. So that means these two are wrong. These two are wrong. Okay. Now go for option C. Option C. Q of t plus 1 equal to. Here in this case they have mentioned A equal to 1. A equal to 1. Just substitute here. Directly I am writing. A equal to 1 means 1 bar is 0. That means this term is getting 0. You are having A value 1. So that means you are getting Q of t bar. Q of t bar. Yes. Whatever they have mentioned, it is correct. It is correct. Now go for the last option. Option D. Q of t plus 1 equal to. Here A value is 0. A value 0 means the second term will be 0. Here 0 bar is 1. So that means you are getting Q of t. Yes, whatever they have mentioned, it is correct. So in this way, whenever they mention MS cube, you have to verify option by option carefully, because we don't know really how many correct options are there, right? So you have to carefully check whether that particular option is really correct or not. Whenever it is MCQ, obviously one option will be correct. If you are able to eliminate 3 options, from there you can choose the other leftover option. Okay. But for MSQ, you have to carefully check option by option. Okay. That is very, very important. I hope it is clear for everyone. Okay. Now, whatever the equation we got, I will write once again. Q of t plus 1 equal to, we got the characteristic equation like this. Q of t plus 1 equal to a bar q plus a q bar. A bar q plus a q bar. This is the characteristic equation they have given. A bar q plus a q bar. Okay. Sometime they will give the circuit and they will give the 4 choices regarding state diagram. You have to choose among the given choices which one is correct, like that. Okay. So here it is very simple, because see, whenever you are having one flip-flop, that means you are having one normal output. If you are having 2 flip-flops, you will be having 2 normal outputs. Okay. So accordingly, since you are having only one normal output, so that means we will consider that particular bit can be either 0 or that particular bit can be 1. Only 2 combinations you will get. Okay. So that means here I am considering that particular state value as 0. Okay. And other combination is 1. That state can be either 0 or 1. Okay. If you are having 2 such flip-flops like 0, 0, 0, 1, 1, 0, 1, 1, like that 4 combinations you will get. Okay. So here state is nothing but whatever the flip-flop normal output you are having, that one we will call it as state. Okay, right. So here just consider when a equal to 0, what is going to happen. Just substitute in this equation. If a equal to 0, what is happen? This term you will get 0. 0 bar is 1. So that means you are getting q of t. When a equal to 0, your next state is same as present state. Okay. When a equal to 0, your next state is same as present state. Okay. So now, say for example, if the flip-flop output is 0, okay, that time if you are making a value 0, that means it will remain in the same state. Okay. Suppose if your flip-flop output is currently 1, and if you are giving a value as 0, that means it will remain in the same state. That is the meaning. I am repeating once again, because since you are having one flip-flop, okay, that particular output can be either 0 or 1, 2 possible cases. For the time being, if that particular flip-flop is in having the value 0, and if you are giving a value 0, it will remain in that state. Or if you are assuming that bit value as 1, and if you are giving a value 0, so that means the flip-flop output will remain in the same state. Okay. Now let us consider other combination. If you are giving a equal to 1, then your next state is what? A equal to 1. 1 bar is 0, so that means the first term is becoming 0. 1 into q bar is nothing but q bar. So that means if you are giving a equal to 1, then what is happening here? Your next state is what? Complement of present state. Your next state is complement of present state. So that means, say for example, if you are currently at bit value 0, and if you are giving a value as 1, then it will go to the next state. Okay. See, if you substitute here q value as 0, 0 bar is what? 1, right? Similarly, if you are currently at bit value 1, and if you are giving a value as 1, complement of 1 is what? 0. So this is the state diagram for the given circuit. That's all. So generally, finite state machine, you are having one concept for EC branch and instrumentation. That finite state machine is nothing but sequence circuit only, synchronous sequence circuit. Okay. Previously, you are having the circuit diagram, and we have analyzed with the help of tabular form. Okay, that is one approach. And this particular state diagram is nothing but it is a kind of flow chart. Say for example, if you are learning C programming, okay, if you want to become master in the C program, okay, you will be having the problem statement. Okay, for that problem statement, what you will do? You have to write ultimately the coding language in the C language program you have to write. Okay. So, but before writing the program, what you used to do in general, when you have started learning in your first year BTech, when you are learning C language, what you have done in your BTech? Whether you have directly written the C program or what you have done? What are the 2 methods you are having before writing the program? Yes, very good Manoj, very good. And others also please respond. What is the other approach? One approach is correct. Yes, very good Manoj. Yeah, very good. Flow chart and algorithm, right? So you will write the step by step what are the steps that particular processor has to execute. Okay, that is one method. Or whatever the steps are there, you can represent in a pictorial form, that is called flow diagram or flow chart, right? In the same way, in order to understand the sequential circuit, okay, one approach is you can have the block diagram or circuit diagram, okay, and then you can analyze with the help of tabular form. And whatever you got, if you want to represent, okay, the regarding the sequence circuit, you can represent in terms of the state diagram. See, it is very simple. You are having one flip flop, that particular flip flop can stay at 0, bit value 0 or bit value 1, right? So if it is transitioning from one state to another state, it is called state transition. Okay, so that's why this particular diagram we will call it as simply state diagram. Okay, so this is nothing but another representation of sequence circuit only. Okay, don't think that finite state machine is completely different topic. Okay, it is nothing but simply sequence circuit only. Whatever the operation is going on, that operation we can represent in terms of the diagram like this. Okay, how many of you liked this question? This question we have framed based on the both combination circuit and sequence circuit. How many of you liked this question, and how many of you felt this is the interesting question? All of you please mention. Yes, very good. Yeah, with this we have completed the 5th chapter. So in this particular chapter, we have discussed the questions based on flip-flops, shift registers and counters. All the important concepts we have covered with the help of questions we have solved, right? Yes, very good, Saptak, Vipin, Manoj. Yes, very good, Revan, very good. Yes. So now let us discuss the questions based on the next chapter, that is data converters. So as the name implies, data converters, we are having two types of converters. One is digital to analog and other one is analog to digital converters. Okay, now let us solve the questions based on these concepts. Yeah, this is the first question, and interesting question, which is MCQ. So that means option will be, only one option will be correct among the 4 choices. Here they have given 4-bit DAC. You are having 4-bit DAC, and here you are given the input in the binary form or digital. Both are same. Okay. See, with respect to our digital circuits point of view, the terms binary and digital you can use as synonyms. But in exact form means there is a slight difference between binary and digital. Binary means you will represent in terms of zeros and ones. That particular values, if you are representing in terms of electrical signals like 0 volt, 5 volt, then that particular signal we will call it as digital. But whereas for this particular course point of view, you can use them as synonymous. Okay. Yeah, Saptak, don't leave. Even though you are from CS branch, okay, don't leave this session. Okay, because in the upcoming questions, okay, you just watch this session. Okay, in the upcoming questions also, sometime we will use the concepts of the previous chapter. Okay, just attend this session completely. Whereas when you are preparing for your exam point of view, that time you can leave this chapter. Okay, CS branch 6th chapter and 7th chapter you can leave, but for the time being, all the branch students must and should stay up to the last. Okay, because this is the last session regarding digital, right? So definitely you will get some glimpse of the previous chapters. Okay, definitely. So here they have given 1101 as the input. When they have given that input, here they are asking the current flowing through this particular load. The current flowing through this particular load, IL they have mentioned. You have to calculate that particular current. Yeah, those who are from CS, okay, you can just watch this session, okay. Whenever related to the concepts of, the previous chapter come, even while we are solving the questions related to the upcoming chapters, but sometime we may use the concepts of the earlier chapters. Whenever similar concept come, that time you can attempt, but for the time being, okay, you can just attend, okay. For one time you can completely watch this session, okay. Yeah, thank you Kundan, thank you Saptak. In the upcoming few questions, we will use the concept of K-map. So please wait, even though you're from CS branch. For this session, you completely watch. See here, they have given a 4-bit digital to analog converter. Okay, so here input is binary or digital form. In the question, they have mentioned input as 1101. 1101 they have given. Now tell me, for 1101, what is the corresponding decimal equivalent? See, I am using the concept of first chapter. I am using the concept of first chapter. Now CS students also can reply, right? This is the number system conversion only. Yes, that's why I told you, you can attend this session completely. Okay, you will get the glimpse of whatever we have discussed earlier. It's a kind of revision, you can say, for other branches, right? 1101 is nothing but 13. Okay, so the output of this digital to analog converter, for the time being, I am considering it as, say for example, V1. Okay, so for a DAC, the analog output will be what? The decimal equivalent of binary into resolution. Resolution is nothing but the reference voltage or full scale voltage or maximum voltage, all are same, divide by 2 power n. So here they have mentioned reference voltage as 5 volt and the number of bits are 4. Reference voltage is 5 and the number of bits are 4. So 2 power 4. 5 by 2 power 4. So that means 13 into 5 is nothing but 65. Divided by 2 power 4 is nothing but 16. So just do the calculation and tell me how much value you are going to get. Yeah, Manoj, you can use that formula also. V full scale divided by 2 power n minus 1. But for approximation calculations, so you can avoid that minus 1. Okay. 2 power n minus 1 is, you can make it approximate as 2 power n. All of you tell me how much you are going to get here. You can use your mobile, right? You can do the calculation in your mobile also. You will get 4.0625. All of you please confirm whether you are getting the same answer or not. Units are volts. 4.0625. Yes, very good, Revant. Now just observe. Here you are having op-amp. The non-inverting terminal is connected to ground. Okay. Whenever non-inverting terminal is connected to ground, that time here to the inverting terminal, this particular node voltage will also become 0 volt only. Actually, physically you haven't connected this terminal to the ground, but whenever non-inverting terminal is connected to ground, okay, here also the node voltage will become 0. Okay, that is the virtual short concept. Okay, generally you will learn that particular concept in your analog course, right? Now here you are having op-amp input terminals. Through that there won't be any current flowing. Okay, even at the output side also. Okay, there won't be any current flows in this particular output terminal also. in the input also, output terminals also, zero current flows. Okay. Now if you observe, whatever the current in this direction is flowing, okay, the same current will flow like this. Just apply KCL. Say what I am saying is, in the op amp input terminal there won't be any current flowing. That means whatever the current entering here, the same current will flow like this. Yes or no? So that means now use Ohm's law and tell me how much current is flowing here. Say for example I am labeling, since this current and this current both are same, for the timing I am labeling as IL, because both are same, direction also same, right? So just by using Ohm's law, you will get IL equal to, here across this 2 kilo ohm resistor you are having this voltage 4.0625 you are having. This is the voltage you are having across 2 kilo ohm, and the resistance value is 2K, 2 into 10 power 3. If you do the calculation, you will get 2.03125. 10 power 3, if you bring numerator, it will become 10 power minus 3, which is nothing but milliamperes. So that means the answer for this question is option D, 2.03125 into 10 power minus 3. Yeah, Revant, whenever you are supposed to calculate the gain of this inverting amplifier, then minus this load resistance divided by input resistance. Okay, that is the inverting gain amplifier gain. Okay, but here the question is, the current flowing through this particular load, since the op amp is ideal in general, whatever, while you are solving the questions in the digital, we will assume that it is the ideal. Okay, when it is ideal, there won't be any current flowing here. So whatever current entering here, since there is no current flowing here, obviously the same current will flow like this. Correct? Right. 2.03125 milliamperes. Option D is the correct one. Now the next question, this is the MCQ. Only one option will be correct. This is the question based on ADC, analog to digital converters. Yeah, thank you, Nikhil. You will learn related to virtual short concept in your analog course. And most of the op amp questions are very, very important. Op amp in the analog circuit subject, op amps are having very good weightage. So regarding analog, you will learn. Okay, regarding op amps, you will learn in the analog subject. Here they are asking the ratio of maximum conversion time of counter type ADC with that of Saxo approximation type ADC. They are asking the ratio of maximum conversion times. So that means the resultant value won't be having any units. Okay. And here both the ADC, they have considered number of bits as 8. So that means n equal to 8. n equal to 8. I hope all of you know the standard formulas regarding maximum conversion time. So regarding counter type ADC, I am assuming it as T1. The maximum conversion time of counter type ADC as T1. So for generalized case, 2 power n minus 1 clock cycles you require. Okay. Whereas the maximum conversion time of successive approximation type, I am assuming it as T2. So for successive approximation type ADC, the formula is n times T clock. Whatever the number of bits you have considered, that many clock cycles it requires, the maximum conversion time. Okay. So since they are asking ratio of these two, so T1 by T2, which is nothing but here 2 power n minus 1 into T clock divided by n into T clock. So here T clock will get cancelled. Just substitute n value 8 here. 2 power 8 minus 1 divided by 8. 2 power 8 is 256 minus 1, that is 255 divided by 8. All of you do the calculation. It is a simple calculation. What you are going to get? See, in the exam you are not allowed to use Calci or mobile, right? But this is the class, you can use your mobile. Okay, no issue at all. You can use your mobile and tell me what is the answer you are going to get. I hope all of you are getting 31.875. 31.875. So that means option C is correct. Option C is correct. Okay, so these are the questions related to data converters. So we have discussed one question related to DAC, one question related to ADC. Okay, now let us proceed to the last chapter, that is CMOS logic family. See, in the third chapter we have discussed the logic gates. So there we have discussed whatever the gates you are having, we have just represented the models like symbols, AND gate, OR gate, etc. All the logic gates. But here in this, actually inside any logic gate you will be having the transistors, right? So with the whatever the set of components that you are using for implementing a particular logic gate or logical function, those set of components together we will call it as logic family. Here we are using one term CMOS. C stands for complementary, MOS means metal oxide semiconductor. So here you will be having two types of transistors. One is NMOS, other one is PMOS. The functionality of these two are complement to each other. Say for example, if this is on, this PMOS transistor will be off, or if this is on, this will be off, like that, vice versa. Okay. So since these two are complement to each other, accordingly the name CMOS has given. Okay. So here we will discuss the question related to, they will give one CMOS circuit, they will ask what is the output, and other variety of question you will expect from this particular chapter is, in order to implement a particular logic function or a particular logic gate, how many NMOS PMOS transistor pairs we require. See, say for example, if you are using 5 NMOS transistors, we will use same number for PMOS also, like 5 NMOS, 5 PMOS. This combination together we will call it as pair. Okay, right. So now let us solve the questions based on these two concepts one by one. So this is the MCQ question. They have given one CMOS circuit and they are asking the corresponding output. They are asking corresponding output. All of you try this question. So here you are having NMOS transistor and here you are having PMOS transistors. So now for this question, if you observe the options, you are having options related to what? Your second chapter. So that's why I told earlier, even though we are solving the questions of the upcoming chapters, but we will use the concepts of the earlier chapters. See here, in the CMOS logic, okay, you will be having, in general, you will be having supply voltage VDD, okay, and here you are having ground. Ground means 0 volt, okay. You are having VDD, that is a supply, or 5 volt, and you are having 0 volt, okay. Between these two, okay, if you observe here, here you are having one output line, okay. So in general, between supply voltage VDD and the output, we will connect the PMOS transistors, and between this output line and ground, we will connect the NMOS transistors. Here PMOS logic will be there, here NMOS logic will be there. This is the first stage. Similarly, here also if you observe, between VDD and output, you are having the PMOS transistors. Between output and ground, you are having NMOS transistors, okay. In CMOS logic, we will connect the transistors like this, okay. If this transistor is on, the corresponding transistor here will be off, and similarly vice versa, okay, right. So whenever you want to write the output, it is very simple. Say for example, the output of this line, I am assuming it as say F1, okay. For the timing, just remove this part. If you are having only this circuit, see, whenever you want to write the output, it is very simple, just look at, see, forget about this part, you just look at only this part. With the help of this one, you can write the output expression, okay. Now whatever the transistors here you are having, just treat them as like switches, okay. Here one switch is there, here another switch is there, okay. Now all of you please respond. If I want to connect this output F1, this output line, to the ground, if I want to connect this output line to the ground, how many combinations I am having? You just consider these two transistors as switches. If this switch is closed, then this output will be connected to ground, or if this switch is closed, this output is connected to ground, or if both the switches are closed, then also output is connected to ground. Yes or no? 3 combinations are there. And even if you analyze like this, whenever switches are connected in parallel, which logical operation we will use? Whenever switches are connected in parallel, which logical operation we will use? Which logical operator we will use? Yes, it is logical OR, right? Logical OR. Here you are having B variable, here you are having C variable. So that means here F1 equal to B plus C. Among these two, you are performing logical OR operation. Now see the most interesting thing here. Here you are having NMOS transistor. So that means this is the gate terminal, this is the drain terminal, this is the source terminal. Similarly, this is the gate terminal, this is the drain terminal, this is the source terminal. Okay. So here what we are telling, when the switch is closed, that means, say for example, if VGS is greater than 0 volt, then only this NMOS transistor will be on. Okay, so that means if you are giving bit value 1 or bit value 5, so sorry, if the bit value 1 or 5 volt, okay, then you are having VGS as what? Greater than 0. So that means NMOS transistor will be on. Here on means what? Drain and source terminals will be shorted. Drain and source terminals will be shorted. So that means it is acting like a switch, simple logic. Okay, similarly here also. Whenever you are giving bit value 1 here, okay, that time here drain and source will be shorted. Okay, or even when you give both the gate terminals having 5 volt, then also both the switches will be closed. So that means, so total 3 combinations you are getting, that is a logical OR operation. Up to here I hope it is clear for everyone. But now the most interesting thing here it is, here bit value 1 you are giving, that is nothing but 5 volt. Okay, when you are giving 5 volt here, what is happening? The output line is connecting to ground. So that means what? When you are giving logic high at the input side, you are getting logic low at the output side. So that means we have to put complement on top of it. So in CMOS logic, by default, from where you are taking the output, you will get the output function by default in the complement version. Okay, see, in order to make these two transistors off, you have to give 0 volt. Okay, that time what will happen? These two transistors will be on. So that time this output line will be connected to VDD like that. Okay, I hope it is clear. Up to the first stage, we got the output function. Okay, now let us proceed further. Just focus between output line and ground only in order to write the output expression. Here you are having one transistor NMOS, here also one transistor NMOS. Here the input is A, here the input is nothing but this F1. Here you are having parallel connection, that's why we have performed logical OR. Whereas here these two transistors are connected in series. Series means we will use logical AND operation. Series means logical AND operation, right? So that means F equal to here inputs are F1 and then A. Among these two we are performing logical AND. Just like here, from where you are taking the output, by default you will get the complement version. That is the beauty of CMOS logic. Now just apply De Morgan's law. F1 bar plus A bar. Okay, here F1 you are having B plus C whole bar. So you have to perform complement. So that means you will get B plus C. Whenever you are performing 2 times complement, you will get the same function. And then you are having A bar. So I am just arranging in the normal order, like A bar plus B plus C in the alphabets, A, B, C order I am writing. Now just cross check. A bar plus B plus C. We don't have here, so it is wrong. Option B is wrong. Here you are having A bar B C, that is wrong. Okay, now let us verify. See, here you are having max term 4, here min term 4. That is not min term, so you can eliminate. So obviously one option is left over, that is option D. Here they have mentioned M4, yes. Here A bar you are having, that means A value is 1. Here B and C are normal, so zeros. 100 is nothing but 4. It is the max term. So in the second chapter we have mentioned that if the number of literals is equal to the number of given variables, then that particular sum term or logical OR term we will call it as max term. Okay, I hope it is clear for everyone. Now let us proceed to the last question. So this is the NIT question. Here they are asking the minimum number of NMOS PMOS transistor pairs required for implementing the Boolean function f of ABCD equal to, they have given pi capital M, that means product of maximums they have given. All of you do the simplification of this function by using K-map. All of you just do the simplification of this function by using K-map. See, now we are solving the question of last chapter, but we are using the concept of second chapter. Okay, so this question, irrespective of branch, EC, electrical, INCS, all the branch students can do the simplification. All of you do it. I'm just drawing the K-map, 4 variable K-map. So all of you try. All of you mention after solving this given function by using K-map, what is the expression you are going to get? All of you try. This is the last question regarding distress acute subject. All of you do the simplification by using K-map. See here they have given max terms, so that means in the respective positions we have to place the zeros, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So first you have to place the zeros in the respective max term positions. After that, just you have to do the grouping of zeros. So here you can do the grouping of these 4 zeros. So row wise A value is 0, that means A plus column wise D value is 1, that means D bar. Okay. Next, you can do the grouping of these 4 zeros. So regarding this, row wise A value is 1, that means A bar, and column wise D value is 0, that means D. Okay, so here you got 2 groupings, both the groupings are compulsory, right? So that means the simplified function f of ABCD equal to, just multiply these two, A plus D bar into A bar plus D. A plus D bar into A bar plus D. Okay. So here A into A bar is 0. You will get A into D plus D bar into A bar. You can write as A bar D bar, and D bar into D is nothing but 0. Right. So AD plus A bar D bar is nothing but what? A XNOR D. A XNOR D. AD plus A bar D bar is nothing but A XNOR D. Okay. Now, after doing the simplification, we got A XNOR D. This is a simplified function. Now, the question is what? You have to implement this function with the help of CMOS logic. In that, when you have implemented with the help of circuit diagram, how many NMOS transistors we require? And obviously, the same number will be PMOS. Together, we will call it as pair. That's all. Just count how many NMOS required. The same number will be for PMOS. Together, pair means obviously the same number. Okay. Now here the interesting thing is this one. We have got the final simplified function as A XNOR D. A XNOR D we got. If you observe the previous circuit, previous question, we have mentioned that whenever you are having the CMOS logic, from where you are taking the output, by default you will get the output in the complement version, right? But here you don't have any complement. So what we can do, just apply 2 times complement, or otherwise this A XNOR D, this AX NOR D, what you can do? You can write it as complement of XOR. Complement of XOR. Okay. See, if you want, you can perform 2 times complement, and with the help of that also you can implement. But here the question is regarding minimum number, right? So you will get minimum number if you can write like this. If you can write like this. Obviously, even if you apply, okay, you can check later for other case. But for the time being, I will discuss this case. Okay. So what I have done is, since you are having the function in the normal form, I have written that function as complement of some other function. Since we know that XNOR and XOR are complement each other, so just represent AX NOR D as complement of AX NOR D. Okay. Now just write this expression. AX NOR D is nothing but A bar D plus A into D bar. And you are having external complement as it is. External complement as it is. Okay. Now let us focus. See, for the time being, just remove the second term. For the time being, just remove the second term. What you are having? By default, you will get the complement version in CMOS logic. So there is no confusion there. Now, here you are having 2 variables, A bar and D. Here the operator is logical AND. Logical AND means we have to connect 2 NMOS transistors in series, right? Yeah, Amit, you are almost closer to the answer. Okay, we'll see. Here you are having logical AND operator. Logical AND means we will use NMOS transistors in series. Okay, first focus with respect to NMOS. Okay, so we have to connect NMOS in series. 2 NMOS transistors in series. So for the timing, let us draw that circuit. So I am considering 2 NMOS transistors. Here the input is A bar. For the other NMOS, the input is D. The other input is D. Okay. Now, similarly, for the timing, just remove this particular term, first term. If you are having only this term, A into D bar. Okay. So here among these 2 variables, once again same logical AND. So once again you require 2 NMOS in series. 2 NMOS in series. Here the input is A and the other input is D bar. Okay. I hope up to this point it is clear. Here you are having A bar and D logical AND, so I have connected NMOS in series. Here AD bar, so I have connected 2 NMOS in series. Now what you have to do? Here if NMOS are in series, the corresponding PMOS will be parallel. So here I will consider 2 PMOS transistors in parallel. Okay. So here the inputs are A bar D. A bar D. Here I have connected NMOS in series, the corresponding PMOS will be in parallel. Okay. So here NMOS in series, the corresponding PMOS once again in parallel. Here the inputs are A and D bar. Okay. Here series connection means here parallel. Here series connection parallel, like that. Okay. And then what we have to do? Just observe. Forget about this complement. Here you are having one NMOS logic like this. Here you are having one more NMOS logic like this. Now among these 2, you are performing logical OR operation. Logical OR operation means parallel connection. Here if NMOS sections are connected parallel, that means the corresponding PMOS sections, we will connect them in series. Okay. So this here we will connect to VDD, and these 2 points we will join. This is the PMOS logic, this is NMOS logic. We will connect them, and from that common point we will take the output. Okay, I hope it is clear for everyone. Between output and ground, we will connect the NMOS transistors. Between supply and output, we will connect the PMOS transistors. Okay. If NMOS is on, the corresponding PMOS is off, or if PMOS is on, the corresponding NMOS is off, like that, vice versa. Okay. Now, here you are having A bar, here you are having D bar. Okay. So, for A bar, we require one CMOS inverter. So, just like, see, just like here I have told, in the same way you can draw regarding CMOS inverter. See, here I am getting A bar. So, under the complement you are having only single variable. So, that means I have to consider only one NMOS transistor, obviously one PMOS transistor. For both the gate terminals, we will give the input as A, output you will get A bar. Output you will get A bar. Okay. Similarly, the case for D bar also. So, here D is the input, output is D bar. Output is D bar. Okay. So, now just count. For overall circuit, how many NMOS you require? Here 1, 2, 3, 4, and then here 5th one, here 6th one, right? So, total 6 NMOS transistors are there. Similarly, total 6 PMOS transistors are there, right? So, the number of NMOS PMOS transistor pairs are 6. 6 NMOS PMOS transistor pairs. Okay. Is it clear, Amit? Total we require 6 NMOS PMOS transistor pairs. Since the question is regarding minimum number, the answer will be 6. Answer will be 6. Okay, I hope it is clear for everyone. So, with this we have completed the last chapter also. So, in this particular chapter, we have discussed one question related to the output of CMOS circuit, and other question is related to minimum number of NMOS PMOS transistor pairs. So, total we have discussed 3 sessions. In 3 sessions, we have discussed all the 5 chapters, all the 7 chapters of digital circuit subject, out of which first 5 chapters are common for all the 4 branches, whereas 6th chapter data converters is common for EC electrical ion, whereas the last chapter is common for EC and ion. Okay, I hope all of you learned a lot from all these 3 sessions, and I hope all of you got the confidence from this digital circuit subject, right? I hope that even, say for example, immediately after my today's session, okay, if you are having your GATE exam regarding digital circuit subject, you will definitely attempt the questions with confidence and you can maximize your score in the digital circuit subject. Okay, right. So, now I will give the brief overview about our programs. So, some of the students are having the inquiries related in our IMS GATE Academy, what are the programs that we are offering. So, when you log in our website imsindia.com, so first click on the GATE mechanical. So, after that you will get the web page. Okay, so there you can see the complete courses which we are offering. So, in IMS GATE Academy, there are 4 programs. First one is classroom program, second one is hybrid classroom, then exclusive live online program, and then self-learning program. These are the 4 programs which we are offering. So, in the classroom program, there will be total 750 plus hours. All the classes will be in the offline mode, and here you will get around 22 to 30 books, which includes theory books, exercise books, and 4,000 plus practice questions. And you will get GATE previous questions, and you are having access of doubt solving portal, and you are having access of my plan sessions, and then test series together we are having 130 plus. Various tests will be there, like chapter test, subject test, multiple subject test, full length mock test, etc. And then post GATE guidance. And then we are having hybrid classroom program. So, here also the number of hours will be same, but out of which 2/3 classes will be in the offline mode and 1/3 classes will be in the online mode. And rest everything, whatever the features we have discussed earlier, you will get the same thing, and here you will get GATE online live access also. and then exclusively live online program. Here all the classes will be in the completely online mode, and rest everything, what are the features we have discussed, it will be same. And then self-learning program, here you will get 400 plus hours of recorded video lectures, okay. And then you will get the books and doubt solving portal, gate question bank, etc., test series access, etc. Okay, and in our IMS we will follow this methodology LPT. So first we will teach the concepts in the physical classes or in the online based on your enrollment, okay. So you will learn the concepts. Once if you learn the concepts, you can solve the questions, okay, by using from your exercise books or gate question bank, etc., okay. And if you are having any doubts, you can get access through the doubt solving platform. And once if you learned and then practice good number of questions in order to know what is your confidence about the subject, then we are having good number of tests, okay. 130 plus tests are available. So these are the various tests and the number of tests, number of questions and duration, marks, everything mentioned here. And here IMS GATE Academy is providing one special feature, that is you are having the access of GATE at 0 fee. You don't need to pay even single rupee, okay, just you have to enroll, okay. In the imsindia.com, when you click, first select GATE ME, after that you can select the respect to your branch and then just enroll for free, okay. So once if you enroll, you will get the access of all this 100 plus hours of concept video, 12 chapter tests, 6 subject tests, 6 previous GATE papers. You will get access of all this without paying single rupee, okay. So whether you are preparing for 2023 or 2024 or 2025, okay, since this is for free of cost, all of you can have the access of all this just by enrolling, okay. You don't need to pay even single rupee, and you will get whatever our products we are offering. You can have the glimpse, okay. You can have the access and you can gain the knowledge, okay. And then this is the portal. Once if the student enroll, okay, they will get the access of this portal. And this is one of the most important feature that we are having, that is the doubt solving portal. So whenever student practice any questions, if they're having any doubts, okay, so the registered students can post their doubt, okay, here just by selecting the subject, and whatever the question they are having, they just click the screenshot of that one, they can upload here. Our faculty team within 24 hours will resolve the corresponding student doubt, okay. This is one of the most important feature that we are offering. And then the next one of the most important feature that we are offering is my plan session. In general, whenever students want to have one-to-one interaction with the faculty in order to get the guidance regarding the preparation, or what are the doubts they might be having regarding the subject, if they want to have any personal thing regarding their preparation, all those things in order to get the proper guidance, right? So here we are offering one-to-one mentoring session and one-to-many also. So this is all about our programs, okay. So all of you can share this particular information with your student, with your juniors or with your friends, okay, so that all of you can benefit, okay, because it is offering that 0 fee program, okay. So whatever I have mentioned, the features regarding 0 fee program, so you are having the access of that. Yeah, thank you, Vipin. I hope all of you learned a lot from our digital circuit subject from the last 2 sessions and today's 3rd session also. So with this we have completed regarding digital circuit subject GATE score booster, okay. I hope all of you learned a lot and gained the confidence a lot, okay. So those who are from EC branch and computer science branch, okay, day after tomorrow we are having the GATE score booster session on COA subject, computer organization. So our faculty Vijay Garwal sir will take that session. So those who are from EC and CS branch, they can attend on Tuesday regarding COA GATE score booster session. Whereas for electrical and instrumentation, our expert faculty Nikhil sir will take regarding measurement subject, okay. Those who are from electrical and instrumentation, they can attend GATE score booster session on measurements, okay. Regarding mechanical, our expert faculty Vijay sir will take regarding manufacturing. Okay, so the students from mechanical, they can attend that particular GATE score booster session. So all of you kindly share our video links with all of your friends, and according to your respective branch, you can attend your respective subject which is going in live, so that you all will get maximum benefit from all these sessions, right? And definitely you can score maximum, you can maximize your score in the coming GATE exam, right? Yeah, thank you everyone for your kind cooperation. Yes. Yeah, thank you Apeksha. Thank you Vipin. Apeksha, if you are the enrolled student, you are having the access of LMS Doubts portal. Okay, if you are not the enrolled student, then you can have the access of zero fee program. Yeah, thank you everyone.